Other examples, solving equations using inverse operations. So again, we want to follow the steps outlined above here. And every once in a while, there's going to be variations to these steps, but generally these 5 steps will serve you well for the majority of the problems we see. So there's no parentheses, so we can skip step 1. Step 2 says combine like terms on each side. Well, the right side only has 1 term, so nothing to combine there. The left side has 2 terms, but one of those terms has an x and one of those doesn't. So there are no like terms in this problem. So step 2, we can check that off. Step 3, move variables to one side using inverse operations. Again, keyword variables, we only have one variable in this problem. It's 3x. So again, we can skip this step. Step 4, move constants to the other side opposite from the variable. So there's only one constant, there's one constant on the left, one constant on the right. We need to do the inverse operation of subtract 2. Because our goal is to get the variable by itself and we want to move the constants to the other side. So we end up, I'm going to bring down the 3x. Negative 2 plus 2 is just 0. Remember, we don't need to write that, so I'm going to erase it. And on the right side, 6 plus 2 is 8. So that's step 4. And then finally, step 5, multiply or divide to eliminate the coefficient in front of the x term. So remember, this is 3 multiplied by x. So the inverse operation is we're going to divide both sides by 3. 3 divided by 3 is just 1. So that's 1x. We do not need to write the 1. On the right side, 8 divided by 3, we could stick this in the calculator. 3 doesn't go into 8 evenly, so we could just write our answer as 8 over 3. Or if the answer called for a decimal, this would be 2.67. Example 2, x divided by 2 plus 4 equals 10. So again, we can skip step 1. There's no parentheses. Step 2, we can also skip because there's no like terms on each side. This side right here, one term is a positive 4. The other term involves an x. So we can skip that step. We can skip step 3. There's only one variable in the problem, so we don't need to move variables to one side using inverse operations. So that leaves us to step 4, move constants to the other side. So that positive 4, we need to do the inverse operation of adding 4 and subtract it to move it away to the other side, away from the variable. So this leaves us with x divided by 2 equals 6. 4 minus 4 is 0, so I'm going to cross that out. 10 minus 4 is 6. So that's step 4. Step 5, multiply or divide to eliminate the coefficient. So in this problem, we are dividing x by 2. So we need to do the inverse operation and multiply both sides by 2. So we're going to multiply this numerator by 2. So this gives us 2x, 2 multiplied by x divided by 2 equals 12. Well, what is 2 divided by 2? It's just 1. And of course, we don't need to write the 1. There's our answer. X equals 12. Example 3. So let's go through the steps. Step 1, distribute to eliminate parentheses. We do have parentheses, so we need to distribute the negative 3. Negative 3 multiplied by 7 is negative 21, and negative 3 times a negative 2x is a positive 6x. Negative times a negative gives us a positive. So that is step 1, distribute to eliminate parentheses. Step 2, combine like terms on each side. There are no like terms on the left side. There's a constant and then a term with an x. So we can skip step 2. Step 3, move variables to one side. There's only one variable, so we can skip step 3. Step 4, move constants to the other side opposite from the variable. So that means we need to leave the 6x alone and do the inverse operation. Tricky here because we see negative 21 plus 6x. but really we could rewrite this as 6x minus 21. Really, we are subtracting 21 in this problem. I'm not going to rewrite it that way in this problem, but I want you to see that really we are subtracting 21 even though there's a positive sign here. So the inverse operation of a negative 21 is a positive 21, and we're going to do that to both sides of that equal sign. Negative 21 plus 21 is 0. We're going to bring down the positive 6x. 5 plus 21 is 26. And then so finally, that's step 4. Step 5, multiply or divide to eliminate the coefficient. The coefficient is 6. That is 6 multiplied by x. So we're going to divide both sides by 6. 6 divided by 6 is 1x. And then 26 divided by 6, that's going to be a decimal. So I'm just going to leave that as a fraction. I could reduce that because both those numbers are divisible by 2. So this could be reduced to 13 thirds. So 13 thirds is our answer. If you wanted to convert that to a decimal, I believe that's 4.3 repeating. Number 4. So this one's going to challenge our steps. Step 1, distribute to eliminate the parentheses. So the tricky thing here is there's no number in the front of those parentheses, so there's assumed to be 1. So really they've just put those parentheses there to tell you that you're dividing all of 5 minus x by 2. So there's nothing really to distribute, so we can drop the parentheses. Step 2 is combine like terms on each side. So again, there's no like terms because we have a 5 minus x over here. So one's a constant, one's a variable. So we can skip step 2. Step 3 says move variables to one side. We can skip that step. There's only one variable. Step 4, move constants to the other side opposite from the variable. So at this point, you might be thinking, okay, in the past, what I've done is I've subtracted 5 from both sides has been my next step. But really, what would make this a lot easier is to eliminate that fraction. Because if we think about this, what we have is we have two fractions. We have 5 over 2 minus x over 2. They've just rewritten this problem right here. Instead of writing as two fractions, they've written it as one fraction. So what we want to do here, instead of, and we don't really want to split it into two fractions because that's going to get messy too, is let's get rid of the fraction. The fraction makes this a lot more complicated. So what we can do, instead of dividing by 2, we're going to multiply both sides by 2. So normally that's the last step, but in this case, since we're dividing multiple terms by 2, we're going to get rid of that divisor right off the bat. So then what happens is we have a 2 being multiplied by all of 5 minus x, but all of 5 minus x is also being divided by 2. So rather than distribute that 2, let's just divide it out, because we know 2 divided by 2 is just 1. And like always, we could write that 1 out front, but we don't need to. Mature mathematicians know there's an assumed 1 in front of that 5 minus x. And on the right side, we get 8 multiplied by 2 gives us 16. Our next step, now we want to move this. This is a positive 5. Don't get tricked by this negative symbol here in front of the x. The 5 is being added to the negative x. So the inverse operation here is we're going to subtract 5 from that positive 5, and we're going to subtract 5 from 16. 5 minus 5 just gives us 0. We're going to bring down our negative x, and that's going to be 16 minus 5 gives us 11. Mature mathematicians know at this point this is a negative 1 multiplied by x equals 11. Our goal is to solve for x. So we have one additional step, and it is to divide both sides by negative 1. Negative 1 divided by negative 1. A negative divided by negative is a positive. So negative 1 divided by negative 1 is a positive 1x. Don't need to write the positive 1. 11 divided by negative 1 is negative 11.